Okay, the recording has started. So, a quick recap of what we had done till now. Let me go to the dashboard. Also, have to share the screen. All right, guys. So, what we have done till now is we have discussed the initial configuration part. Initial configuration part, right? We try to understand what basically the NGFW means, right? There were quite a few things related to this. The first important one was FDN, which is sort of the threat intelligence center for the Fortinet firewalls. And it's just that it fetches all the databases and it's always in the real-time communication with those servers, which are strategically distributed across the whole world for the reason that your firewall needs to be up to date from the signatures and rest of the databases, right? So you don't have to worry about the zero-day attacks or maybe like any of the attacks that are actually happening around the world. We also try to understand what is the difference between the VM and the hardware, right? This was the second thing that we discussed. And then later on, we try to understand administrators. This was also one of the topics. And we also try to understand what do we exactly mean by the admin profiles, right? Quite a few types of administrators, and you could sort of customize the level of access, which actually is nothing but the admin profile. And then that admin profile sort of contains all the privileges or all the things that you sort of want to assign to an administrator in terms of the level of access. And then based on that, you sort of categorize that, okay, if this particular level of access, which is nothing but the admin profile, is mapped to one of the administrators, based on this particular role, it gets this level of access and you name that. For example, if I try to map one of the administrators with one of the admin profiles called as super user, it means this particular guy to which this admin profile, which is nothing but the super user, is mapped with, it's going to have the complete root access of the Fortigate, right? And not just this, we also try to understand what is meant by the trusted hosts. How many trusted hosts can you actually map with map with the administrators, right? And then we also said that every time you get a box and you're being told that you sort of have to configure it, mount it somewhere in the network, what are the initial configuration aspects that you actually will have to take care of? And how many things were there? If you guys can help me with that. Yeah.
Policies,
Okay.
and then DNS
Okay.
and policies.
Initial configuration aspects. We talked about the DNS. We said static, or you wanna maybe do it with the help of dynamic routing, right? And then you said we're going to take care of the interfaces, and we're also going to take care of the policies. These are the four main aspects that are actually going to help you with the initial configuration part, right? So after this, we also discussed uh, the DSCP, right? We discussed DSCP in detail, and we also discussed an important case in the DSCP, which is DSCP reservation, right? You might have heard about this particular guy. It's sort of a Microsoft Word term, but when you talk about the FortiGate, they don't call it DHCP reservation. They call it IP address assignment rule, right? And we also discussed the forward traffic and local traffic, right? And from this, we also sort of try to explain what is meant by the management plane and the data plane. So this is all that we have sort of finished till now, and yeah, it was sort of a gear that we needed to kick off with to start with, and I guess we're good with now discussing the other factors or other features of this firewall, right? So I'll just move forward with the next topic of discussion, and it's going to be firewall policies, right? So just to give guys a very brief idea, so if I would hand over a router to you guys, what do you actually get out of it? The reason someone will just give you a router and you're being told that you sort of have to configure it and just mount it somewhere in the network, right? You say that, okay, what we might want to do here is we sort of have to configure the interfaces, right? And then we're going to put the routes, right? And maybe you want to define the access list or something else, right? But these two are the main things, right? Anything that you add on top of it might go into the bucket of network security, but from the point of routing interfaces and making sure that the traffic that is being handed over to to these interfaces gets routed, and that you define with the help of the statements you write within the routing table of this particular router. This is all about the router, right? But when you talk about the firewall, right? I'm gonna get one firewall over here. Oh, so this is a firewall, right? It's a Fortinet firewall. What's the difference between the router and a firewall now? See, one of the major categoric difference that I could possibly see here is that people call this it's an L3 device always. It means that if you want to talk about the OSI model, right? Uh, it's going to have the level of access. It's going to have the privileges to strip off the packet up to 3 layers. And when you talk about the third layer, it's nothing but the IP layer, right? So it's going to take care of the IP addresses, and for that reason, you say that the router basically learns based on source IP and forwards based on destination IP, right? If I would just pick up any one guy over here, right, and I sort of want to communicate with you, and you are a router, right? The moment I forward a packet to you, you're going to strip off the information from that packet. You look at the third layer of the OSI model, you check that particular information, and you're going to see that, okay, this is the source IP in this packet. So let me just keep it with me and sort of have to learn the source IP. And then let me check the what is the destination IP. Okay, it's that guy which is sort of connected to me via this particular hop, right? And you say that, okay, if this is the destination, let me just check in my routing table if I have a route to this particular packet. And that's what you say that that's why you say that you forward the packet based on the destination IP. Now, if I talk about the firewall, firewall is a full-blown router as well, right? It's a router, no doubt. Now, the only thing that you're actually adding on top of the router is you sort of go ahead with the L4, L5, L6, and L7, right? So you say my firewall can become an L7 device, right? It can become the L6 device, L5 device, L4 device, right? But by default, any firewall, it's a full-blown router. That means it's capable of routing, right? It definitely has the privileges privileges to strip off your packet up to layer 3. And this is a very important case. Now the thing is, if I have a routing in place over here on this router, right? I sort of send out a packet, packet A. It's going to look for the source IP over here. It's going to learn that, and then it's going to look for the DIP, which is the destination IP, and it says that okay, I sort of have to make a route lookup in my routing table, and then I'm going to forward this particular packet to that particular destination, right? And that's how you do it. So it forwards the packet, right? Now, if I talk about this particular firewall, right, which is a full-blown router, the reason why this particular firewall is not going to send the packet down or maybe through it is because it's an idiot router, right? Now the question is, why do I call it an idiot router, right? The point here is that as long as I don't write any statement out here and say that, okay, hey man, you're a router, no doubt, and we're going to hand over a packet A to you, right? It's a packet A, you just sort of have to check the source IP and the destination IP. Right. You're going to do the same procedure. You sort of learn that source IP and you sort of want to forward the packet with the help of the routing table, and you check the destination IP and say that I'm going to forward this packet with the help of whatever the route is present in me, right? But then I won't do it because nobody told me to do it. That is the whole point here. So unless and until you don't tell a firewall that you have to sort of allow a traffic, it would always deny it. That's the reason people call it, I'm not calling it, people call it it's an idiot router, right? So you're sending the same packet to this. It's capable of doing the routing, but then something needs to be added to this firewall. It needs to be told that you have to get the source IP, get this particular destination IP, look for a map, or sorry, look for a match, and then sort of make it through this particular firewall, right? And those things, those statements that you sort of write over here, these are called policies. These are the firewall policies, right? So these are nothing but the statements you write to tell firewall to forward which traffic, right? This is the whole debate of the policies. Why a policy is actually needed in a firewall, right? It's definitely a full-blown router. It's just okay to do the routing and all, but its inherent behavior is that it would never pass a traffic through it. And it's very important. I'm talking about a packet which is trying to go through it, right? I'm talking about a packet which is trying to go through this, right? Any packet that sort of wants to go through the firewall, right, would always be denied if there is no policy defined in this firewall. And the reason why it denies because a firewall always has one policy, which is called implicit deny, right? And it's because of this particular policy, it's always going to sort of block the traffic that wants to go through it. Now, what happens to the packets that actually want to sort of touch the firewall and come back, right? By the way, what is this traffic called which wants to go through the firewall? Anyone? Yeah? Traffic that wants to go through the firewall, what's it called? All right. That surprises me because we have discussed this. Any traffic that wants to go through the firewall is called forward traffic, right? And any traffic that wants to touch the firewall or maybe gets any traffic that gets originated from the firewall, it's called local traffic, right? Now here's a kick. So I'm going to make a table over here now. When we're talking about the forward traffic, right? It's also called through traffic, right? It sort of goes hand in hand with the firewall policies, right? I sort of wanted to make a handshake over here. I'm not sure if I can do that. Yeah, let's assume that this is the handshake happening. Handshake. So forward traffic goes hand in hand with the firewall policies. What that exactly means is if there's a traffic, it wants to go through the firewall from one interface to the other interface. It would always need a firewall policy. And if you don't have a firewall policy, firewall sort of acts as an idiot for this particular traffic, right? Why? Because there's an implicit deny policy defined which denies everything, right? And its policy ID is 0 in 4048. Its policy ID. What's the policy ID? We're going to see very shortly, right? So forward traffic goes hand in hand with the firewall policies. And now if I'm talking about the local traffic, right? It is the traffic that is either to the box or from the box, right? If this is a box over here, right? Someone is just coming and touching this particular interface and coming back, right? Or maybe if anything from this box tries to go to the internet, for example, the Fortigate traffic, right? This firewall is trying to download the packages from FDN, right? So that particular traffic, I name it packages over here, it gets originated from this box and goes to the FDN, right? So this particular traffic, which just originates from the firewall, or that traffic that just terminates on the box, right, on the firewall, it's called local traffic, and it does not need the firewall policies. No policies required, right? You don't have to write the statements for this, and this is very critical part. Just give me 1 second. Let me just grab the charger, and then we can continue. Guys, give me 1 second. I'll be back. Any questions till now before we proceed?
No question.
No questions. Everything clear?
Yes.
Okay. Let's check what a firewall policy actually looks like in the topology, right? So I'll come here. This is a topology that I have made till now. It was already a pre-configured lab. We had done this lab earlier. It's a very basic lab. We're going to repeat this lab to sort of try to demonstrate what a firewall policy actually looks like and what can we basically achieve while configuring the firewall policies. Mubin, I see you muting, unmuting. I saw that a couple of times. So if you have any question, just feel free to ask. Uh, They're probably speaking and yeah, not audible. Mubin, do you have any question? Okay, please carry on. All right. Okay, so let me just come to the firewall over here. I want to see what is the IP address of this. So admin 123 is the password that I kept for this one. I want to check the IP address, diag IP address list. 192.168.136.129 is the IP address that I would be using. So it's Control C, Control W. Come here. Okay, it's already open tab for this. So admin and then 123. So where we actually see the policies is you move to the policy and objects. I'm going to come here. This is the firewall policy, right? I don't have defined any firewall policy in this one. And for that reason, we called this, I mean, we should have not called it, but yeah, people called it. So that's the reason we just add it for the heck of it, right? So we're not defined any policy here. And for that reason, you call it an idiot router, right? It's capable of doing the routing, but it won't do, right? And the reason it's not going to allow any of the traffic through it is because of this particular policy, right? This policy is implicit deny, right? It says that anything that wants to go to anything, right? And it's scheduled for all the time, right? Every service is including you here. And when we're basically talking about the services, we're actually talking about the ports, right? It's going to deny it, right? Now, what I want to say to this particular firewall is, hey man, okay, I know that by default your inherent behavior is that you block everything, you don't allow anything through you. But now that I have a requirement that I have a couple of people over here, right? Let me just call this the same guy. He's an IT guy over here, right? And we're gonna rename this. This is not an L1 engineer anymore. We sort of say that this is a finance guy, right? And we probably need one more. Let me just check if I have any configuration over here. So this is sort of a setup that I want to basically create over here. We'll create multiple people over here who are sitting behind the switch. They have a requirement of going to the internet for different reasons. Right? And then we'll see what we could sort of do with the policies, how we can configure the policies, right? So I'll just turn this switch off. I will call one more guy over here. Uh, Linux, and then I'm gonna get the smaller version connected to this switch, and I'm gonna call this guy over here. I say this is from the HR department, so it's HR guy, right? So what we are going to do here is now, let me just turn this on. This one is already on. This one is already on. If I come to the firewall, if I talk about the port 2, which is basically facing the LAN, right? It doesn't have any configuration now, right? So what I will be doing now is I'll be making sure that this particular VLAN, this particular IT guy belongs to a specific VLAN from the point of security. And this guy also belongs to a separate VLAN, and this guy also belongs to a separate VLAN, right? And then based on those VLANs, we're going to create multiple set of policies on this, right? And this particular guy will be having the default gateway defined on the firewall, right? It's going to be an SVI, switch VLAN interface. How we create that, we're going to see shortly. Likewise, this one also will be having uh, SVI defined on the firewall, and this guy also will be having SVI defined on the firewall, right? So it's going to be a very descriptive lab. We have done it earlier, but we're going to repeat this because we're now sort of making a deep dive into the firewall policies. So what I'm gonna do here is I will just define an IP address word. Give me an IP real quick. Yeah,
192.168.1.1.
1.1. Okay. We're going to keep it /24 and we name it VLAN 10, right? This guy is belonging to the VLAN 10. Give me the other IP.
192.168.2.1.
2.1/24. This is the other guy. Now give me the third one. 192.168.3.1.
192.168. Yeah.
Okay. All right. So let's just check if I have the IP addresses defined for these people now. I'll just try to configure them statically. I come here, command prompt. I'm gonna do ncpa.cpl, ncpa.cpl. It's going to take me to the adapters. Come to this one and then go to the IPv4. So 192.168.1.1. Let's keep the gateway as 192.168. What is this? 192.168.1. Let's keep it 10. DNS, I'm gonna keep it 1.1.1.1, 8.8.8.8. All right. And if I do IP configure here, okay, IP config, IP config. Yeah, this is the correct IP now for this one. So we're done with this. Let's come to this guy now. Is it already open or let me just close the Palo Alto over here, VNCs. What is this? I'm gonna close this one as well. Let's do it from the scratch. So I'll open the other guy, the finance guy, and I'm going to configure this one as for the IP address. So I'll come here, go to the net manager, and go to the properties over here. So I'll change the IP address over. So I'll have to disconnect first. Fill it. Okay. Okay. Disconnect. Properties. Now let me just make it 2.1, and then this guy becomes 2.10. The DNS is fine, so I'll click on OK and then I'll click on connect. Right. So this one looks fine. Let's come to the third guy now. He's from the HR department, so we're sort of having, being the network administrators, we're just configuring his PC for the IP addressing. We would have done it via the DHCP because nobody does the manual IP configuration for the PCs. But only reason we want to I mean, do the manual IP configuration because we want to take control of the things, right? Otherwise, manual configuration is not recommended. So I'll come here. I'm gonna keep it 192.168.3.1, and then this has to be 255. Okay. This is going to be 3.10, and then DNS server 1.1.1.1. It's going to be 8.8.8.8. I'm going to click on OK, and then I'm going to connect. Now, all the three guys coming with the different IP addresses belonging to the different VLANs, right, are connected to the switch. So I'm going to come to the switch and I just have to make sure that all the three interfaces, just log the lab over here first. Yeah. So on the switch, what I'm going to do here is I'll just assign the VLANs to all these guys. So if I just do show int stats first, show int stats, too many ports. So we're going to start with the Ethernet 0/0, and it seems to be connected with the IT guy. So I do config t int Ethernet 0/0. How do I assign the VLAN to an interface? Yeah. Switchboard mode access, switchboard access VLAN 10. Switchboard access VLAN 10, right? So it's creating the VLAN. Let's hope it does that. Okay, now the other thing is I want to also attach a description. So I'm going to do description. I say VLAN 10 IT. And then I do show int stats. VLAN 10 is assigned to this. We just get rid of this one. So if I want to check, bring this down, make it a little smaller. If I do show VLAN brief, okay, 10 is there and it's part of the Ethernet 0/0. Now let's come to the next one, config T Ethernet 0/1, and I want to do switch port mode access. Switch port access VLAN 20, something that we defined for this one. And let's attach the description. I say fin guy, fin, or finance maybe. Now if I are to verify it, I do show int stats. There you go. So it's assigned to the show int stats. Yeah, it's assigned to the VLAN 20. Now let's come to the last one. So the last one is config T int Ethernet. Which one was this? 0/3. I want to do switch port mode access, switch port access VLAN 30. Then attaching the description. This is the HR guy. Show int stats. Okay. So we did 0001 and then 03. So we have 0001 and 03. Now talking about this one, Ethernet 0/2, since it's supposed to carry all the traffic, right, from all these VLANs down to the Fortigate. So this has to be configured as access or trunk.
Run port,
And what's the reason for that?
so that we can allow tagging.
All right, correct. So I'm gonna come to the int Ethernet. I say 0/2. How do I configure it? Switch port trunk encapsulation .1q, and then I'm gonna do switch port mode trunk. I could just put a description out there so that it says that I am basically going in uplink to the firewall. So if I do show int stats, it is defined as the trunk, but it doesn't say I am being, I mean, it doesn't name itself, right? So let's just put a name for this one. So what I'm gonna do here is I'm gonna do config T int Ethernet 0/2. I wanna put a description out here. So it should say uplink to Fortigate. Now if I do show int stats, all right, so the switching part is done, right? Let's come to the firewall now. So on the firewall, I could see there is a single port that's actually connecting me to the switch, right? And I got 3 VLANs to take care of, right? And for that reason, I'm going to create 3 switch VLAN interfaces, 3 SVIs out of port 2, right? So let me come over here, admin. I'm gonna do 1, 2, 3. Later, come to the interfaces, right? I'm going to create a new SVI. I go to the interface. I say it's the first one was IT, right? I say IT VLAN 10, alias is IT interface. I want to get it out of port 2 and the VLAN ID for this is 10. Assign the IP. Let's keep the gateway as 192.168. What was that? 1.10. When I allow the ping, uh, yeah, nothing else needs to be allowed here. So I'll click on OK, right? So you could see that I have uh, got one child interface, which is the SVI out of the port 2. I want to get one more over here. Uh, I name it finance. The other one is finance, right? Yeah, this is finance. So finance, I say VLAN 20. I call it VLAN 20 here as well. And then I'm going to get it out of port 2. I want to keep it 20. And The IP address is 192.168.2.10/24. The ping needs to be allowed here because we just want to test it if we have the connectivity from the PCs to these VLANs to these SVIs which we just got out of the port 2. So let me just get one more over here. The last one was HR. It's VLAN 30. Control C, Control V, port 2. And I'm gonna do 192.168. What's it? 3.10/24. Ping needs to be allowed. I'm click on. All right, so we got all the three. Let's just confirm the testing, confirm if we have the connectivity from all these machines. So I would go to the first PC, which is uh, the IT guy, right? I want to ping the gateway 192.168.1.10. It's reachable, right? And if I want to come to the next one, I go to the shell. I want to check the IP. Its IP is 192.168.2.1, so it's the finance guy. So I want to ping the gateway 192.168.2.10. This one is also fine. So let's check the last one. I want to confirm the IP. It's 3.1. So let's just ping the gateway 192.168.3.10. This one also looks fine, right? Now the point here is I want to send the traffic to the internet, right? All the three guys have this requirement that they want to go to the internet, right? Now, will they be able to go to the internet? The question is yes, no, how do you want to, solve this particular issue, right? If I just come here uh, to one of these guys and I want to maybe say, I want to ping 1.1.1.1 minus t, right? Minus t basically stands for it's going to send the continuous pings to the 1.1.1.1. It's on internet, right? And it doesn't go through, right? And the only reason that it's not able to go through is because there is no policy. And how do we get that? We could possibly check that in the logs. Let me just check if we could see the logs over here. No logs. And again, we might not be able to see the logs because of the licensing issue. But there was this thing that would work sometimes. What was it? For TV sessions. Okay, no logs. Let's try to do the debug flow. So we have done it before as well. Let's try to do it once again. Diag debug flow, filter, ADDR. I'm gonna do 1.1.1.1, or maybe let's keep the source IP 192.168 1.1, right? This particular command tells you that what is the address of that particular flow that you want to debug, right? Now the next one, diag debug flow, filter, okay, trace start 25. I want to get the trace of 25 packets. The other one, diag debug flow show function name enable. I want to see what all the functions of this firewall is actually doing with the traffic. And the last one is diag debug enable, right? Let's see that if we are actually getting here anything. Okay, so what does it say? It says that there was a packet, right? It's proto1. Proto1 basically stands for the ICMP traffic. The protocol number for the ICMP is 1, right? 192.168.1.1 is trying to go to 1.1.1.1, right? It was just trying to allocate a new session for this. It's also looking for a route for this one, right? And then it was denied by the forward policy. It's a forward traffic, but there is no forward policy, right? So this is the reason we need the policies over here. Please remember these 4 commands. It's very important. Diag debug flow filter ADDR 192.168.1.1. Diag debug flow trace start. You're going to sort of put how many packets you actually want to debug. The third one, diag debug show function name enable, which functions you sort of want to apply on the traffic. And the last one is diag debug enable, right? So I'll just close this and I'll come to the firewall policies now. I'll create one policy over here. I say IT to internet. Incoming interface is VLAN 10, not port 2 now, and the outgoing interface is port 1 as per the topology, right? Source is all, destination is all, or maybe let's just keep the source as well over here. I'll just define one source here. I have to create an object for this. Reason why we are creating an object over here is because everything that you're going to use it within the policies has to be defined somewhere, right? And if I have to call an IP address where I cannot just come here and type the IP address, right? It doesn't allow me to do that, right? You have to create an IP address over here, and when you create something, it's basically an object, right? So I'll create an address 192. I name it as IT guy 192.168.1.1/24 and Control C, and this has to be now /32 because it's a single host that will be let to go to the, it's not an IP configuration, right? We're not doing an IP configuration over here, and for that reason, just to allow a single host to go to the internet, you have to make it /32, right? If I would just keep here 24, it means how many valid IPs actually fall in this particular range will be allowed to go to the internet, and that's something that's not my requirement, right? So I'll just put /30 because I got one single PC out there. So I'll click on OK, right? So it wants to go to the internet. The service here is all. I'll just, for the sake of testing, I'm going to do everything. Now let's talk about all these things now. So name, I just named it, right? Incoming interfaces, which is the interface that's actually getting the traffic, right? It's an ingress interface, right? Incoming interface is also called ingress interface. And this outgoing interface is the egress interface through which the traffic actually goes out of the firewall, right? You just imagine yourself within the firewall, you're getting the traffic on the incoming interface, which becomes an ingress interface. It flows out of the firewall through the outgoing interface, which is also called egress interface, right? Source and destination. Source is which source actually wants to go to this particular destination, and destination which is defined it all for the reason that we want to test everything to the internet, right? Schedule schedule stands for uh, sort of the period for which this particular policy is going to stay active, right? I want to keep it always for now, right? Or you could just create a schedule as well. For example, the use case for schedule is that there's a hostel, right? Or yeah, let's talk about the hostel. So the guys actually get the lunch break, and you sort of want to make sure that these guys would get the access to the internet only during the lunch breaks, right? So I could just come here. I could create one-time schedule, right? I can name it, and then I can sort of say that, okay, this is the start date, this is the end date for this one, right? And for how long you sort of want to keep it active, right? This is a one time, and if you want to sort of make it recurring, I say that on Monday from the 1 p.m. Let's make it 1 to the 2, right? 1 p.m. to 2 p.m. Oh, it has to be like this. I'll just try to fit in with the within the example that we actually have. So we're talking about one of the hostels where you sort of want to give access to the people during the lunch break only, and the lunch break is every day between 1 p.m. to, okay, if we're talking about the 1 p.m. it has to be 13, and if we're talking about the 2 p.m. it has to be 14, right? So this is how you sort of would create a schedule for all these situations, right? I would say lunch break internet. I could just call okay, right? I can call it here, and for that reason, and this particular policy would be active during the lunch break only on every day between 1 p.m. to the 2 p.m. But that's not our sort of a case right now. We just want to test the internet for this guy, right? So I'm going to keep the schedule as always. Service is the ports, the destination ports that you basically want to allow, right? So we're going to keep it all for now. Action is accept. We don't want to deny it, right? And then inspection mode is flow based or proxy based, right? Keep it on hold for now. We are going to discuss it very soon when we are going to take the UTM part, right? Now the next thing is firewall network options, right? This particular NAT has to be enabled because I'm coming using a source IP, which is the private IP, right? I want to go to the internet, and everyone who has to actually go to the internet um, has to come using the public IP address, right? And I don't have any public IP of my own, so I would need the firewall's public IP, which is the port one's IP, to go to the internet. And for that reason, this particular option, which is the NAT option, needs to be turned on. And important thing for this particular packet, guys, for this particular uh, policy is that this NAT that you turn on within the policy. Again, the NAT option that you turn on within the policy is always source NAT. I can just write it here for you guys so that you don't forget it. NAT that is turned on within the policy is source NAT. It means that if there was a packet, source IP, destination IP, right? Its IP was 192.168.1.1. Destination IP is 1.1.1. It was supposed to talk to this guy, right? The moment it crosses firewall, right? This particular packet, because of this NAT, is going to, the destination IP won't be touched. It's still going to be 1.1.1.1. The source IP would be the port 1's IP, right? And port 1's IP is 192.168.136.129. It might look like a private IP still, but it's bridged with the physical adapter of this PC because we are running this lab in the EVNG, right? And that whole stuff, how the virtualization and rest of the stuff actually happens over here, that is already explained in the previous lectures, right? So yeah, that is the whole purpose of you using this NAT, right? And it says that, okay, if you want to NAT it, right? Do you want to use the outgoing interface of this particular firewall, right? Of this particular firewall policy? What is the outgoing interface? The outgoing interface is port one. I say yes, right? Or do you want to use anything else? If I choose a dynamic pool, I will have to create that one, right? We will take that up when we are going to discuss NAT in the Fortinet firewall, right? For now, we're just going to do the outgoing interface, right? You want to preserve the source port. Which are the source port that you actually want to come? Do you want to preserve that? Do you want to still keep that intact? I would just leave this option for now because we're going to pick this up again in the uh, when we're going to discuss the NAT, right? Protocol options, we're going to discuss this one in the UTM, right? Security profiles, all these things will come up when we're going to discuss the UTM part, right? Logging options, do you want to log this traffic, right? I'm going to turn this button on and then it says that do you want to log only the security events or all sessions? I would say all sessions, right? Why don't I say security events, right? When we're talking about security events, right? It's actually going to deal with everything that's being done by the UTM, right? So I don't want to just deal with the security events. I want to log each and everything that's actually matching with this particular firewall policy, right? Generate logs when session starts. I would just keep it off because I have everything getting logged for all the sessions. Do you want to capture the packets? I'm not capturing the packets, right? Comments in the production. Whenever you create a firewall policy, you always make sure that you put a ticket number, right? And the date, right? So this is the whole crux of this firewall policy. Now, let me just try to break it down now. See, how many attributes? Just come here. Now, guys, it's an important part now because I'm going to just try to bifurcate this firewall into two things now. And that's why you're going to see that why we're trying to discuss the full-blown router and what is the use case of adding the UTM on top of it, right? Just connect the tab again. Okay, so there you go. So the first thing that over here is uh, firewall policy. My tab is lagging. Hmm. So I say part A, right? The part A would contain incoming interface, outgoing interface, source IP, destination IP, and port, right? These are called 5 tuples, right? And they basically define your route lookup, right? So every time there's a guy that is just hitting this particular interface, right? Its source IP will be checked, right? And then source IP is learned. That's the first thing, right? Then it's going to say that, okay, let me just check the destination IP address now. The destination IP will be checked for the routing table that's actually present in this firewall. And out of the route lookup, you're going to get the outgoing interface, right? And once you get the outgoing interface, you're going to check what is the port that it is basically asking, right? You might get a itty bitty idea of the extended ACL over here. Extended access list. That's how you define it, right? It sort of still is an access list. And that's the reason I just try to bifurcate it. It's part A of the firewall policy, right? And you're going to get 5 tuples out of it. That's how you basically define the session. We're going to discuss sessions in a very, very detail, right? Once you get all this information, right, you're going to look for a firewall policy within the firewall, right? And you're going to come up with an action. This action that you see over here, right? This guy. Let me just come here. I have one more thing over here. So Epic Pen. We open this. Where is it? Hmm. There you go. So I'm gonna keep it here and then I come to the, yeah, this is my pen. So let's discuss this one. So incoming interface, outgoing interface, source, destination, leave the schedule, service, right? These are called 5 tuples, right? And this action that you actually see over here, it's called firewall action, right? Up till here, up to this particular point, right? It is just an extended ACL that is making the checks, right? So whenever a firewall is actually doing the route lookup, it's going to do the route lookup based on 4 things: incoming interface, outgoing interface, source, and destination, right? And then when you want to check whether this particular traffic is allowed or not, you're going to include the service, and then you're also going to look for a particular firewall policy defined within this firewall, right? Which is allowing it, right? So all this traffic that's hitting this firewall, it's trying to go out of the firewall, right? If I have a source, I have a destination, I have a service, and I have a policy saying that action is accept, then only firewall action will say this has to go to the part B. Part B starts from here. Oh damn. Why do I change it? Yeah. Part B starts from here, right? So above one is part A. Now part B starts from here, right? Part B is going to take care of a NAT, right? In the NAT, you basically say that, okay, do I have to NAT it, right? You say yes. Is there any relevant interface that you want to NAT it on, or you want to use a specific IP address? We're going to discuss this whole detail in the when we're going to pick up the NAT. And when you are NATing it, do you want to preserve the source port? Because every time there's a PC, it's generating the traffic. It's always going to mention that, okay, I mean, the packet always would be created layer by layer, right? The physical layer, data link layer, then network, rest of the things, right? So it's always going to have a source port. You want to preserve that? I would say I don't care about that for now, right? And protocol options, we're going to take this up. Once part B is fine, right? Then only you move to the part C. And what is the part C over here? If I would just close this, let's go to the whiteboard first. So we say that part A is basically firewall action. Oh, this is firewall action, right? Or part A is firewall action, right? And what was the part B? Part B was NAT, right? If you have firewall action saying except, then only you go to the part B. This is really important, guys, right? And when you have part B, right, you have a NAT in place, then only you're going to move to the part C, right? Part C is UTM of this. Let's come to the firewall over here. I'll open this one. So when I'm talking about the part C, right, the part C says, get rid of this. Okay. Now the part C, oh, part C is your UTM, right? Only when part A is accept, part B is valid, then only you move to the part C, right? So in the part C, the UTM is actually going to check the signatures of the packets, right? It's going to look for the patterns of the packets to see if it's a valid pattern or not. We're going to discuss that when we are going to pick up uh, the UTM in detail, right? All these things, when they sort of give the disposition that okay, this packet is fine, then only it goes to the next one, and then only your session is created, right? So this is your logging option. It is your part D, right? And logging is sort of independent, right? Independent as in that even if the part is block, it still will be logged, right? As long as you have kept it here, right? And even if part C says that it's not a good packet, it still will be logged because you have created or checked the all sessions over here, right? So based on this discussion, right? If I have to come back here, so we got four. Uh, okay, we got four blocks of firewall policy. The first part is part A. It's uh, firewall action, right? It includes your incoming interface, your outgoing interface, your source IP, your destination IP, and the firewall action, right? You could include the service over here as well, right? And note that these four things are nothing but the route lookup, right? You just do the route lookup and then you say that, okay, let's now check the port and let's see if the action is accept or not. And then only you move to the part B, right? Now part B is your NAT part, right? If this is true, then only this can be checked, right? Now, if this one is also true, then only part C, which is the UTM, right? You're going to look for the patterns, check the antivirus, IPS, and web filter. We're going to discuss all those, right? And if this one is also true, then part D will still happen, right? If, I mean, this one is permanent, this guy, so it's permanent, right? And if part A is saying that I don't just allow this particular traffic, it still will be logged because you just define within that same policy that you want to define this particular packet or not, right? So this is logging, right? You want to log this traffic. So these are the four uh, aspects of a particular firewall policy, where the first section would check for the firewall action. If the firewall action is always based on just IP things, right? It's still IP thing. The firewall action would just take care of the five tuples, the incoming interface, outgoing interface, source IP, destination IP of corresponding interfaces, which actually map with the corresponding interfaces. right? The service and then action, right? And then you sort of take care of the NAT, which is the part B, right? And then the UTM action is checked, right? So this is UTM action, right? And this is firewall action, right? This is your NAT, and then this is logging, right? So this is the complete sort of a breakdown of a particular firewall policy. We're going to move with more detailed aspects in our upcoming session, and then yeah, we should be good with this one. I could just come here and say okay now. Okay, so there you go. I have the policy now. Now will it be going to the, there you go. So the PC is able to get to the internet now. Now if I would just come here and check what's happening with my debug flow, diag debug flow filter ADDR 192.168.1.1, diag debug flow trace start 25, diag debug flow show function name enable, diag debug enable. There you go. So it says, okay, it's already created the session. It's just offloading all those sessions now, right? If I want to check what exactly is happening with this, I'll just clear the session diag system session filter 192.168.1.1, and then oh, it has to be source diag system session clear. Now let's just do this one more time. Diag debug flow ADDR. I want to trace it. Okay, there you go. So okay, it's still offloading it. Let me just show you the policy lookup here in the firewall policy as well. So if I have to do, I mean, if I have a list of firewall policies over here, right? And then I want to see that I have the source, I have the destination as well. I know the incoming interface as well. I want to check if there's a particular policy present or not, right? No doubt you could see that in the debugs as well, but in the production environments, there's a very huge traffic and it might be uh, a little complicated for you to sort of figure out the correct debugs, right? So I'll come here. My incoming interfaces, I'm behind SVI VLAN 10, and the traffic that I'm basically going for is ICMP. I want to keep ping request for now, right? And my IP is 192.168.1.1. My destination is 1.1.1.1. I want to search for this, right? And there you go. It's hitting this particular policy, right? Just starts blinking out here. So this is the whole purpose that why you have a firewall policy in place. And again, every time this firewall policy tries to look for a match, it's going to do this in top-down approach, right? Just explain that one and then we should be good with closing this one. Clearing the screen. So if I have a list of firewall policies over here, right? So okay, if I have policy A and then policy B, C, D, E, F, and then in the end I have deny, right? Deny is red. I call it implicit deny. Is 1, 2, 3, 4, 5, 6, 7, 8. Right? Whenever the packet hits the firewall, right? It's incoming, it's outgoing, right? It has source IP, destination IP, and then service, and then action, right? We're just talking about the part A, which is the firewall action, right? It's going to look for the match like this, right? It is the top-down approach, or people just say it first come first serve or something. Top-down approach, right? If you don't have a policy, what would happen? It's always, in any case, going to hit this policy, which is the implicit deny. And for that reason, You say that if you don't tell a firewall what to allow, which is in the form of these statements that you customize over here, which are nothing but the firewall policies, we just created one, right? If you don't have defined, if you have not told this firewall what to allow, right? It's always going to act dumb because of this particular policy. It's always going to block you, right? So, yeah, I'll just close this discussion of firewall policies over here for now. We'll have the new session, another session for this one in the next week. If you have any questions, please go ahead.
Hi, Nazir. Can you hear me?
Yeah, I can hear you moving. Yeah,
Okay. Yeah, I actually pasted in the chat. I think I was having issue with the microphone. If you don't, can you open the chat?
yeah.
Yeah, I want to know the difference between the. Oh, it's not coming there. The flow based. Yeah, this thing. Yeah. Can you
Okay.
explain the inspection mode? Yeah, I just wanted we saw
Uh,
there.
I could have just taken it maybe in the future because it's still not making a lot of sense in the beginning. But yeah, let's have a brief discussion on this one. So when we're talking about the flow based, right? Just make sort of a 10,000 top view of this. This is my firewall over here, right? And you're just bombarding the packets over here, right? It's a single file and it's in the form of packets. I call it packet 1, 2, 3, 4, 5, and then 99, right? 99. The total number of packets for this file is 100, right? And we're talking about the flow based, right? The name itself suggests that the firewall is sort of going to make inspection of this particular flow in the form of a continuous action. Yeah, this is lagging a lot, right? It's continuous action. So it gets the packet A, right, or packet 1, right, checks it and forwards it, and then gets the packet 2, checks it and forwards it, gets the packet 3, checks it and forwards it, gets the packet 4, checks it, forwards it. Now the question here is the file is of 100 packets, right? And you're just checking all the packets. You have given out, you have passed 99 packets because of the flow based inspection, right? In the flow based, it's like you give me the first packet, I check it and forward it. I'm not going to buffer the whole file for now and then look for if there's anything wrong with this, right? It's packet by packet analysis. So the 99 packets are quite fine. Now the 100th is a monster, right? So 100th packet tells me that, hey man, the pattern of this packet looks like to be a faulty one. If you're sort of trying to send a PDF file, that's what the name suggests, or that's what the format suggests. But to me, the pattern or the signature doesn't match with the PDF, right? So what would happen with this, and what will happen with the rest of the packets, right? It's going to drop this packet for sure, right? And the and the file that actually went to the client over here, right? It's going to be an unexecutable format. The client will never be able to execute that. So that means you're still protected, right? So it's packet by packet analysis where you sort of get the packet and then forward it, and then if at any stage you sort of would say that this particular packet is not fine, right? Then you'll just discard that particular packet, and anything that has already been sent out, that will never be capable of being opened or anything you call it, right? Let's talk about the other one. When I'm talking about the proxy based, right? The name suggests it means that I'm going to proxy over here, and for that you'll have to do something, right? What we have to do, we're going to see that in the future, right? It's sort of if I need to get the privileges of opening the file over here, right? Then checking the patterns and all the rest of the things, right? I'll have to do something over here, and we just take this. So what happens in the proxy based is that this firewall is going to wait. If you're supposed to send him the 100 packets of file, it's going to get all the 100 packets here only, right? and then sort of make all the UTM decisions, um, everything that you activated on this one, be it web filter, IPS, antivirus, right, DNS filter, whatever it is, file filter, could be anything. Or if you want to check the application layer packets, right, with the help of SSL decryption, it's going to look for that one as well, right? And then only if it finds that this one is fine, right, then then only it's actually going to pass it through the firewall to the client, right? Now, again, one of the worst cases that could be possible here is that you sort of try to scan this particular file for the any of the infections, right? And it actually has any infection. What would happen? It's going to discard this, right? Proxy seems to be a very strong part of inspection, a very reliable one, but it's happening on the toll of uh, the performance, right? And when I'm talking about the performance, right, it's always causing the delay, right? It will cause the slowness, and not just this. When I'm talking about the performance, it's CPU intensive and it is resource intensive and it's memory intensive as well, right? So if you have a very basic firewall, for example, you're just talking about the 40F firewall, 60F firewall, right? You do it and then your firewall goes into the conserve mode. It just sort of claiming, hey man, just I'm just running short of memory, right? Because you sort of want to buffer all the things that your clients are dealing with, and then you make all these inspections. So for that reason, people don't usually go with the proxy ones, right? They're okay with the flow ones, flow based inspection. Any further questions on this one, Mubin, or maybe from your side, Nikhil?
No questions.
No question. Thank you very much, Nazir.
All
No
right,
problem.
so I'll see you in the next session. Uh, Again, it's still going to make a very much uh, more deep dive into the firewall policy. There's a lot that we need to discuss. So yeah, stay in touch. Thank you, everyone. Please take care. Bye.
Thank you.
Okay, bye. Most probably it will be next Sunday, right, Nazir?
Next Sunday, yeah.
And you
I'll
will
try
tell
to.
us.
I mean, if I have the bandwidth, maybe in the week, within the week somewhere, I'll just try to
Sure,
have
sure.
one more session to compensate for the one that we just missed last week, right?
Okay,
And yeah, if it doesn't, then again Sunday will be
sure.
the next session. Yeah. All right, guys. Please take care. Bye, everyone. Thank you.
Bye. Thank you,
Bye.
Nazir.